It's Addy from Attitude World, and today we're going to look at two ways in which we can calculate a Fibonacci number associated with an index. So just so you guys know what a Fibonacci series is, here's a quick background. So Fibonacci number is a number from the series, the first term of which is 1, and the second term of the series is also 1. And the third term is obtained by adding the second and the first term. So every term after the third term is obtained by adding the previous term and the term before that. So nth term will be n minus 1th term plus n minus 2th term, or second term. So the third term will be second plus first, which is 1 plus 1, and that gives us 2. Similarly, the fourth term is 2 plus 1, that gives us 3. And so on. So that's the Fibonacci sequence, and Fibonacci number is a term in that sequence. So the agenda for this tutorial is to obtain or to write a function that outputs a Fibonacci number associated with an index. And there's two major ways we can do it. One of the ways is just the basic formula. We can write a recursive function and you guys can see I'm using Java here. So Java class called Fibonacci has a recursive function that I wrote called get Fibonacci number that passes an index. So if it's the 0th term, it'll return 0, and if it's the first term, it will return 1, and the second term will be the 0th term plus the first term, which is 0 plus 1 and 1. So here's our recursive statement, and these two are our boundary statements. So this essentially is the Fibonacci number function, pretty straightforward. And since we have two ways, I decided to use system.nanotime to find out the duration of the program and see what function is actually better, the recursive one or the other one. So again, we are finding Fibonacci numbers associated with 5 indices, and 3 should return 2, 4 should return 3, and the 10th index should return 55, and so on. And again, calculating the time in nanoseconds. I don't think we would have required nanoseconds, but just to be on the safer side, I guess microseconds would have done in this case, but it's never too bad to use nanoseconds. Now, similarly, we have a program called Enhanced Fibonacci. Now, this uses a formula that was derived using some really cool exponential series generating function. If you guys don't know what generating function is, you guys can always look it up, and I'll make another video in which I will explain the proof of this formula. So basically, the formula is right here. It is the power, the golden mean, which is this number, 1 plus the square root of 5 divided by 2, to the power of the index that we want, the Fibonacci number, and golden associate, which is 1 minus the square root of 5 divided by 2 to the index, the whole thing divided by square root of 5. I know it's a very random equation. We don't even know what square root of 5 came up with. So it has a couple of really cool proofs, which I will go over in my next video. So I thought, let's use this formula to find out the Fibonacci number. Sometimes there are cases in which this formula does not return an integer. So you have to approximate it with either cast it as an integer. In other cases, it is, in most of the cases, it's very accurate. And again, we're using nanotime to calculate the duration of the program, and we have the same indices that we kept trying to calculate the Fibonacci number of. So let's go and run these programs. I've compiled them already, and let's run the Fibonacci first. It's Java, if I can type Fibonacci. Yeah, they return the numbers that we expect: 2, 3, 55, 89, 144. And let's run the enhanced Fibonacci. And by the way, I'm sorry, I totally forgot. The duration was about 160,000. Is that what it is? Or no, it's actually 1,600,000 nanoseconds. Okay, now let's see the enhanced Fibonacci. Wow, there's a huge difference. This is just 537,000. So it is 3 times as fast as the regular Fibonacci. So it is indeed enhanced Fibonacci. And let's see the reason why. The reason is that, okay, Fibonacci is an ON function, and you know, if you're trying to calculate the nth Fibonacci number, you have to calculate n minus 1, n minus 2, and so on. So it is potentially an ON function, and enhanced Fibonacci is also an ON function because math.power is an ON function. To calculate the power of something to the power n, it takes n iterations. So I'm assuming power is faster than a lot faster than this function. That's the only reason why it is. But in terms of big O, these two functions should not have a huge difference as you increase the number of terms. But clearly, if they had to pick one, I guess, yeah, the enhanced Fibonacci is indeed enhanced. So yeah, these are the 2 ways we can calculate Fibonacci functions. You guys can always find these code on my website, and links to which are as usual in the description below. So yeah, feel free to comment and like, and don't forget to subscribe. See ya.